Hey, welcome back. In this video, we'll be talking about market risk. This is from chapter 6. There's no mini exercise associated with this video, but we'll be looking at slides 22 through 29 of chapter 6. So let's get into it. To recap, we left off measuring risk with standard deviation, right? And we said that captured total risk, total variation in an investment's return. That includes market risk, right? Market-wide factors, recessions, changes in interest rates, inflation, pandemic, right? All firms are affected by these market-wide risks. And then it also included company-unique risk, right? CEO illness, things like that, company-specific risks that are eliminated through diversification. So we want a way to measure market risk because we can't eliminate it through diversification. So let's take a look at that. All right, so our measure of market risk is going to be beta, and it really just involves measuring how a stock's return changes as the overall market changes, right? How does the stock perform relative to the overall market? So the overall market will measure as the S&P 500 return, the 500 large cap stocks overall return. That'll be how we measure the market return. And just beta measures how a stock's return changes as the market return changes. So with this hypothetical example, Foster House Gourmet Foods, we've got 6 months of historical data, and you can see we've got every month we've got the market return and Foster House's return. And you can see that every single month the Foster House's return is exactly twice the magnitude of the market return, right? First month, market's up 2%, Foster House is up twice as much, 4%. Second month, market is down 1%, Foster House is down twice as much. So Foster House's return is always twice the market return, so that corresponds to a beta of 2. So you can see Foster House's return moves more than the market on average. So that measures market risk. If we plot this data on a coordinate plane, on the x-axis is the overall market return, right? On the y-axis is Foster House's stock return. Those same data points, we just plot them on this plane. The slope of the line is going to be 2. That corresponds to a beta of 2. So in practice, right, if we estimate stocks betas in real life, the stock and market returns aren't perfectly correlated like this. So here's some actual data for measuring a stock's beta. And we've got historical stock and market return. Stock return on the y-axis, market return on the x-axis, right? And so each of these is a historical monthly return. And so you can see here's 1 month when the market is up and Starbucks is up. Here's Starbucks beta. And then here's a month where the market is up just a little bit, but Starbucks is way down. So they don't move in lockstep with one another. But if we fit a trend line through this data, like a regression line, if you've seen that, the slope of the line is called beta, and that's the stock's beta, right? So Starbucks has a beta of 1.2. So let's interpret that. Right? Starbucks beta 1.2. So that means on average, when the market moves by 1%, Starbucks stock moves by 1.2%. So we can see that Starbucks return tends to move more than the market overall, right? So beta measures market risk. High beta equals high market risk. Okay. And actually, some good things to keep in mind, right? If beta is less than 1, a stock has less market risk than the overall market. These would be good things to write down. If a stock has a beta greater than 1, that means the stock has more market risk than the overall market. If a stock has a beta equal to 1, the stock has the same market risk, level of market risk as the overall market. All right, so beta measures market risk. So here's some stock betas, right? Amazon has a beta of 1.57. So on average, the market moves 1%. Amazon's return moves 1.57%. So it moves more than the overall market. All right. Coca-Cola and Pepsi, they have less market risk than the overall market. Okay, so beta measures market risk. Higher beta means more market risk. Good. All right, so we've already seen that diversification eliminates company unique risk, but it doesn't eliminate market risk. So to manage market risk, we can have a portfolio of either high beta stocks or low beta stocks, right? And that's what this shows here. We see that a portfolio's beta is just a weighted average of the individual stock betas. So let's do this little example. Let's conclude with this little example where we've got a 3-stock portfolio, 25% in Hertz Rent-A-Car, right? High beta stock, lots of market risk. 25% in Boeing, medium beta stock. This is not, yeah, and then McDonald's, a low beta stock, right? Not much market risk. People go to McDonald's whether the economy is doing great or whether it's doing terrible. So not much business cycle sensitivity. But a portfolio of these, a beta of a portfolio like this, it'd just be a weighted average of the individual stock betas. So let me show you how the math gets set up, and then if you want to plug in the numbers on your own and try to figure it out, you're welcome to. Portfolio beta, and that's example 6.4, 6-4, right? So portfolio beta equals, for this portfolio, our weight in Hertz, 25%, right? Which I would decimalize, times Hertz's beta, which is 2.16, plus our weight in Boeing, 25%, 5, times the beta of Boeing, weight in Boeing times the beta of Boeing, 1.33, plus our weight in McDonald's, 50% of the portfolio is in McDonald's, times McDonald's beta, which is 0.38. So a portfolio's beta is just a weighted average of the individual stock betas. I'll let you work out this math on your own if you like. The solution is down here in the notes section of the PowerPoint if you drag this up. But let's be ready to compute a portfolio's beta when we're evaluated on this. All right, so beta measures market risk, and we manage market risk by either investing in high beta stocks or low beta stocks. Nice work with the video. Thanks as always for tuning in. We'll talk to you next time.